Thank you, Kathy and the ProDairy team for inviting me to speak today. We're going to spend the majority of today discussing basically reading reports or data that we can gather from robots specific to the maintenance of them, so maintaining them, as well as how we can use them to troubleshoot, monitor, maintain, improve milk quality. So the objectives, understand the importance of monitoring robot function. I think this is important because we'll go through this, but we need to think about the idea of how many cows or how many individual milkings are taking place at a robot at that individual milking unit compared to even in a large parlor. And we'll go through that thought process. In my mind, robot success relies on monitoring reports. I can't stress it enough. If you're not someone who's willing to look at a computer, you're going to struggle with making robots successful. And then being able to use the technology that's at your fingertips, but being able to mine all the data that's there, but not use it to try and outguess the biology of the cow. So quickly, we'll go through a little history, why robotics, and then we'll get into management and milk quality. Just a little bit on the current status. This is a couple years old, but first robot was in the Netherlands in the early 90s, late 90s. They came to Canada, in the U.S. We're over 30,000 robots now worldwide, 10,000 farms. And the point here, I think we'll go to the next slide, but the trend right now is definitely larger, more commercial robotic installations. I think when robots really first hit the market in the U.S., we saw a lot of 1 and 2, maybe up to 4 robots. And now, at the end of 2016, in my discussion with a few of the robotic manufacturers, there was over 20 installations slated across the U.S. with 12 or more robots. So I think that's going to be the future. And we're also seeing currently 2 companies working on robotic rotaries. A little bit on the data here on the number of robots. The largest in North America to be installed is 24 robots. I do now think that has been surpassed by another one that's going in. And then the largest in the world that I know of will be completed in Chile with 64 robots. So it's not this just small 1 or 2 robots for 60 or 120 cows. It's going to the, to the commercial side. I'm sure many of you are aware, but why do producers choose robots? Flexibility in schedule, so more time away, able to go to the kids or grandkids, basketball game, or maybe just a little bit too physical, maybe, on the body, working in a tie stall facility. Labor efficiency, so ability to work in other areas of the farm. I have to say, labor efficiency is present, it is relevant, but I don't think it's there until you start getting to that 3 or 4 robots. I've yet to see a farm install 2 robots and be able to eliminate labor. I think it's just the switch. There is efficiency in labor if you can focus on another area that was your weak link in management, be it repro, crops, calves, and so on, and improve the overall efficiency. Maybe it shouldn't say just labor, but the overall efficiency of the farm as a whole. And then a third reason is information. There are people that are very excited about the technology, the ability to be proactive or manage the cow sooner and have all these repeated measures day after day, milking after milking at the quarter level of the cow. So kind of just starting a little bit here on the equipment side, I like to put this up as somebody who used to work for an equipment manufacturer. I heard too often that equipment was the reason that cows got mastitis, or one of the main reasons. And if we look at this pie chart, we can see that the work that Graham Mean did, the milking machine is really only responsible for 20% of the contribution to mastitis. Herd management, milking management, that human side has 60% and the other is the cow. So 3 ways that cows get mastitis from equipment: irregular vacuum fluctuations or liner slips. It's probably a little bit less of an issue in a robot compared to a conventional parlor because we have individual the claw is at the level of the quarter. Each teat cup is attached to a quarter. So if we have a line or slip, it may only affect that one quarter, not the whole claw and multiple quarters. Teat damage from over milking, so where we get congestion at the teat end, where the teat end remains open longer, or long-term hyperkeratosis. Again, probably a little bit less of an issue if a robot is tuned up and functioning properly, because we have individual quarter takeoffs. When a quarter is done milking, that teat cup comes off. It doesn't stay on till the last one is done, like we have in a claw. Transfer of contagious organisms, or just transfer of organisms, is probably the biggest factor with robots. And we'll go through this when we discuss the number of cows that are milked per milking unit or per robot exceeds what we see even in large commercial parlors. So that's the one where we've really got to minimize that risk of the robot being the vector to transfer mastitis-causing organisms. Robot myths, two things to go through here. I think I often hear that robots prevent or decrease the incidence of mastitis. I don't think it's prevention, but I think it's proactive management. The fact that we have values at the level of the quarter multiple times a day, from 2 to maybe 6 times a day, the cow becomes her own control, and we can measure deviations within the cow. I think that becomes more proactive management in terms of, we may decrease the severity, but we're not going to decrease the incidence. And then the number of cows milked in a robot per day, I think in my mind there's been this mindset that if we only have 60 cows per robot, there can't be many milkings per robot. And in fact, again, as I said, we'll go through this, but there's many more milkings per individual milking unit in a robot than we can get in a large dairy. So which has more milkings per milking unit? Milking 120 cows 3 times a day with 2 robots, or milking 4,500 cows 3 times daily with a 100-stall rotary? And to go through that, we'll look, if you milk 120 cows with 2 robots 3 times a day, that's 180 milkings per robot, or per milking unit. Even at the more typical 2.7, 2.8 milkings per day, you're at 162 milkings per individual robot. If you take 4,500 cows on a 100-stall rotary, it's only 135 milkings per unit. So the risk or the importance of making sure the equipment is functioning properly is even greater in a robot than it is in any other milking center that we have. So that's why I highlighted the whole, minimize the risk of the robot being the vector to transfer mastitis. And that is the reason I'm putting a lot of focus in this talk on reading reports and the importance of daily maintenance or monitoring of, the functionality of the robotic milking equipment. So robotic management in general, I think it comes down to initially, we're talking about managing the report. So we've already, we're done with barn design, but in the initial phases, barn design is important because it's the one variable that it's really permanent. And I think it's important to determine how much interaction you're going to have, hopefully limited interaction, and if you want free flow versus forced flow with cows in terms of cow traffic. But barn design, cow traffic, and then robot settings, the number of milkings allowed, interval between milkings, maximum box time, these all play into the amount of pounds you can harvest per robot, the number of milkings per cow, and so on. I do believe very strongly the 2 areas, if you're going to make an equation for robot success, it's barn design and monitoring reports. And those are questions I think you have to ask yourself at the onset. Should we retrofit a barn or should we build new? And am I willing to change my management or hire someone to manage at the level of the computer first and then go monitor and read the cows? Okay, on to management. Routine tasks, so management of the mechanics of the robot. There's daily, weekly, monthly, there's routine service. Most manufacturers today actually have an agreement in place that you can sign with them in terms of having them do limited preventive or scheduled maintenance or being, more of a Cadillac style and doing a lot of it, they all usually require some sort of agreement for the first few years that you allow certain checks to be done and so on. But given that we have moving parts in a mechanical arm, cameras, lasers, there's all kinds of things from just simple manual cleaning and getting organic matter off the camera to calibrating sensors and making sure that we've got stuff greased up and lubricated. The one thing I've learned in my years of working with milking equipment and watching automation increase is that oftentimes we think with increased automation, it leads to less manual cleaning or manual maintenance. And I think it's just the opposite. The more automation there is, the more we have to at least monitor to make sure that we can check out and complete certain manual tasks in a timely manner. So manage records or reports. So it's both cows and equipment, and I think at a minimum, reports need to be done twice daily. And if you're doing them twice daily, they need to be 12 hours apart. Just based on how the software gathers data and so on, twice a day is the minimum. 3 times is even better. So equipment monitoring, this is just a screenshot from some stuff from Laley at the bottom, but robots will inform you if there's a mechanical issue related to certain things. So either preventive maintenance, like liners need to be changed, there's something wrong with a certain sleeve or a diaphragm, tells you if feed is low. This type of information actually can be sent to your phone. It's on the, the home screen when you go into the software, even to the point where it'll tell you that a certain robot is having a longer average milking time compared to its normal, or, compared to the average. And that's important because typically when that happens, that's usually not a cow issue. That's a robot, a mechanical issue, and we need to address that so it doesn't lead to downstream issues of it becoming a cow issue with, clinical mastitis and so on. In my discussion with a dairy producer that has Galaxy robots, Galaxy, the one interesting thing, I'm going to throw a few tidbits in here and there about certain companies that I've worked with. The one thing that they require that I think is very good is they require all people who are, or owners who purchase a robot to go to basically a technician school to learn about monitoring and servicing the robot. It doesn't mean when you get home you have to service it, but it means you understand what the key areas are. You can talk the language. It makes everything easier. In that discussion, the herdsman informed me that he spends 8 hours a week on routine or scheduled maintenance that may be daily, weekly, bi-weekly, monthly tasks. So the way it works out on a weekly basis, he's got 8 hours out of a 10-hour day or whatever it is. Just this is for 2 robots, but 8 hours from cleaning lenses in the area around the laser, checking that each liner is pulsating, monitoring stuff for tears, listening for air leaks, the greasing, checking fluids, all that stuff. Monthly, you look at or graph pulsators, check claw vacuum. Maintenance costs on robots anywhere from $7,000 to $12,000 annually. So that is what I'm going to call the cost of ownership. So hygiene and service. That's not any sort of breakdown. You have a faulty pulsator and it needs to be replaced. This is just hygiene, routine service, replacing of wear items that get replaced over time. Service and repairs annually is probably in that $2,000 per robot, and I would say that's fairly conservative. If you're a farm that's actually, pays attention, is mechanically inclined, it's probably less. If you do less mechanical stuff, it's probably more.
Rick, this is Kathy. Can I interrupt for just a second?
You bet.
Can you tell me what that maintenance from 7,000 to 12,000, is that, first of all, is that per robot? And also, why such a wide spread? That's $5,000 difference.
The biggest thing there is based on some of the service plans that people have. Some of the service plans that people have signed up for, as well as some of this routine maintenance or this hygiene and service. Some of this farms are doing on their own where other ones aren't. Okay, so the $12,000 would be what you would pay out of pocket to an equipment dealer. People who are doing $7,000 are doing more of it on the farm. The ones who are doing $12,000 are having more of it done out of house.
So does the barn design and the management of stalls and all that, does that impact the cost as well? I'm thinking from the hygiene perspective.
Sure. I mean, anytime you use something like sand, you're going to have more wear and tear. So I would expect these costs to be a little higher, potentially with sand versus, maybe manure solids or something like sawdust.
Okay. Right. Thanks, Rick.
So equipment monitoring. So monitor robots, for equipment functions. These are just a few examples, but front teats, as compared to front teats, should not differ by more than 20 seconds for milking time. Okay, so the two front teats, same thing with the rear teats. They should not differ more than 20 seconds for milking time. And when you take the average and look at it across cows, if we start seeing more than a 20-second difference from the left front to the right front, I'm actually going to, to me, that's an attention related to the mechanics of the robot, not a cow milking more on the left front versus the right front. And multiple robots in the same pen should have similar, box or milking time. So there's, just like we used to have individual cow versus pen or herd level management, we can kind of see that too with robots if we have multiple in a pen. They should be somewhat similar. And then we can look at the amount of time and low flow or fluctuating vacuum. There's different things you can look at there, just touching on a few here. And I don't know if there's any specifics, but we can go through them if there are any questions at a certain time. Failed or incomplete milkings is one that I look at a lot. So, do failed or incomplete milkings happen because of faulty milking equipment or because of the cow? And the answer is both. We can't say because there was a failed milking that the cow had mastitis. It could also be equipment failure. It could be there's a tear in a liner, so we don't have, proper vacuum or pulsation, So this is where monitoring reports, and I'll show you an example of a report here in a minute with failed milkings or milking time. But it's important when you start seeing a lot of failed milkings that you go check if there's multiple robots. Is it on one robot versus the other? Is it on one quarter versus the other? And if you start seeing a pattern where it's on robot, you got 4 robots and it's on robot number 2 on the left hind, that's probably a mechanical issue. If there's failed milkings and you have 10 of them and there's, 3 on 2 robots and 2 on the others, then maybe it's more of a cow issue, So it's truly something going on with the cow. And limiting these becomes really important. If you're working with a farm that is maxed out on their time to get cows milked in their robots, a failed milking is 4 or 5 minutes of lost milking time. And we're talking if you're milking 60 cows on a robot and you're getting 3x milking out of these cows, you need to be less than 6 minutes from when the cow enters to when the cow exits. Well, we just lost a whole milking here for a failed milking. So we really got to reduce these if we want to maintain, 2.7, 2.8, up to 3 milkings on these robots. Can't say enough about cameras for monitoring. The more we go to robotics, the more we're moving ourselves away from walking out to get cows and moving them to the parlor. So you need to install cameras to monitor. They're a great way to look at traffic patterns, bottlenecks. It's amazing what I've learned about subordinate and dominant cows and thinking that something's going on with the design of the barn when it's actually the free flow of cows. And I'll show an example here. And a dominant cow not letting a cow go in, and you think the cow may have mastitis or something because she hasn't milked or has another health problem, when in reality, she's just not allowed to go there because of a dominant cow. So why are cows bunching at the entrance and exit area of a robot? You know, without a camera, we wouldn't know. It could be cooling, could be flies in another area, it could be, you know, related to cooling, it could be sun on another end of the barn. So getting fetch cows, this is a really, you know, an interesting one. When do we go get cows that, you know, we got an alert that said they haven't milked in 12 hours? When do we go get them? I'm a proponent of trying to get fetch cows at the same time you're completing another task in the pen. So if it's when you're going through to scrape stalls and you're going to get other cows just naturally are going to get up, make that the time that you go interact with the cow, so it's not just a one-on-one between you and the cow. There may be some other cows that you're moving around a little bit or jostling around. So you have multiple cow interactions and tasks completed at once, even though you're only targeting 1 or 2 cows. Here's an example. On the left, the cow looking back at me. Subordinate cow, we went and fetched it, put it in a little isolation pen where the cow can go directly into the robot. Problem is, right outside the pen, there's a dominant cow that's sticking her head through and is not going to let this cow go in and milk. She's going to either go in or she's going to stay there. Not ideal, but at certain times, you know, we do need to just move these cows right into the robot. We, you know, try to limit that because they get used to it. Cows are creatures of habit. The more often we have to go get them, the worse it becomes for fetching them. It's not, we want to get cows to go through these robots, you know, 2.5, 3 times a day. It's not a bad idea, or it's okay sometimes if a cow goes 12, 14, even 16 hours versus every 12 hours you're going out to get it. Maybe you need to push the limit just a little bit and let them see if they're going to go. If they don't, obviously you need to go get them. This I just threw in there. These are some milking time parameters for you guys to look at, but these are some targets that I use when first monitoring a farm, you know, on are we getting enough cows through? Are we even meeting the minimums? After we have that and the herd's been baseline, then we measure them against themselves. So milk quality, how do we use the robot? You know, how do we determine if a cow has mastitis or the early onset? How did we do this in a tie stall or a parlor? We looked for clots or flakes, right? Abnormal milk, bloody or watery milk, again, abnormal. Swollen or hard quarter is some sort of inflammation, decreased milk production. You know, worst case scenario, we got a down cow. We used a CMT to look at somatic cells. So the robot is no different. We'll go through what they measure and how it's similar, but we can't use the technology that's at our hands to outguess the biology of the cow. And I mean that from, we're using a robot in the same way we did before. You know, abnormal milk, there's color sensors, so they determine if there's bloody milk. Temperature of the milk, so we know that milk temperature will change, can change if there's a swollen or a hard quarter, some sort of inflammation. Milk deviation, so decreased milk production. We can see that now at the level of the quarter instead of the level of the udder. Milking time, you know, really short. Maybe the cow kicked it off because she was uncomfortable, maybe just really long. And then conductivity would be where CMT comes in. So there's nothing new here other than we're using technology, we're using software to monitor this, but do it daily and at the level of the quarter. And that's where it becomes really, really powerful, and we can get a lot of information. Just one last thing in terms of cow evaluation or treatment. It's highly recommended that you do not treat cows in a robot. The one difference of treating cows in a robot versus a parlor, in a robot, you know, we're talking about free flow, or the cow is voluntarily moving to the robot to milk. Anytime we do any sort of interaction in the robot that is not comfortable to the cow or makes her not want to come back, that's a real negative, or it really hampers our ability to get the number of cows we want through the number of times a day. So as I was saying earlier, the cow becomes her own control in the robot, and not only is she her own control, she's her own control at the level of the quarter. So we get multiple repeated measures within cow multiple times a day. So we can quickly say, we only want to see 1.5 or 2 pounds difference at the level of the quarter before we flag for her to be monitored, or, like I said, 20 seconds different in milking time at the level of a quarter, we're going to flag her to go monitor this. So here's some, what data can we gather from the robot in terms of looking at, anything health related and monitoring the milk. So milk yield, flow rates, time, conductivity, SCC, color, teat position, attachment attempts, so the number of time it takes to get a successful attachment, pre-milking prep time, and then at the udder level, milk yield, fat, protein, lactose. A lot of these are indicators. They're not true values, so just based on the software, they're good indicators though, but they are measuring the same way, same algorithm over time. So, we should be very sensitive in terms of measuring or monitoring changes. Cow level, we can use activity, rumination. Rumination, I think, is amazing in terms of what it does or how it correlates to mastitis. Cows who get mastitis tend to drop in rumination. So, I guess it makes sense. They're not feeling well, and where we normally see normal ruminations with these tags from 450 to 500 minutes per day during lactation, these can drop, to less than half that, to less than 250 minutes per day if they have mastitis. So pretty neat stuff that we can continuously monitor. So proactive management, this is where I think the real value comes in the use of the technology and robot, is we have all these values at the level of the quarter. We have to remember we're responding to an immune function. So the cow, there's an invading organism, the immune system responds to it, and those changes are sensed through the sensors, the technology. We're gathering this data, and it allows for proactive management. And proactive management is, somewhat we're still responding, but we're responding even, or we're being reactive, I should say, but we're responding even sooner. So it comes in the form of rapid intervention. So it's kind of like a vaccine in ways that we reduce the severity of some of these negative outcomes. So we can provide supportive therapy or prevent mild mastitis from becoming moderate or systemic by interacting with this cow sooner. It may allow us to get a milk sample quicker and send it in for aerobic culture so we can, manage the organism. So really managing milk quality in the robot is the same as in any other milking center. It requires managing the causative agent or organism. Even though we have so much data here, it's just like cell count. You can't manage the number. You have to manage what causes the change in the number. So you can't manage conductivity, color, temperature, anything like that. There have been some, statements made by robot companies basically saying if you see a rapid increase in conductivity and then a decrease within 24 hours, it's E. coli. Well, maybe that works sometimes, but the only way we're going to know that is by taking a milk sample, culturing it, and managing whatever that causative agent or that organism is. So it's really the same in terms of when we identify a quarter that's off. We get the alert, we go out, we look at it, yep, there's abnormal milk. We still need to collect a milk sample, find out what the organism is, and manage it that way. So how do we use the technology to manage high-risk cows in the herd? And I'm going to use Staph aureus for the example here. There's definitely robot herds or any farms that don't want to get rid of Staph aureus positive cows or chronic cows. So what can we do? How can we use technology? The first way, even without technology, is if we have multiple pens, we can limit these cows, these Staph aureus positive cows or chronic high cell counts, to one pen. That's a great way to at least isolate it to one pen. If we have multiple robots and we have some sort of sort upon exit or sort from one robot to the other, and based on certain manufacturers, we can actually limit the cows to only milk at one robot. So we can say, hey, we only want them at this robot, thus reducing the risk from, down to only the other 60 cows that go in there. You can limit Staph aureus cows to only milk twice a day. You can also limit them to only milk in the 3 or 4 hours prior to the system going through a complete wash. So again, limiting the amount of time that these organisms may remain on some component of that milking unit and be at risk of infecting another cow. We can include some sort of backflush, sanitized steam cycle after these cows go through, so we can make them their own group within a pen. And, so there's so much technology here in ways that you can manage the quality to achieve, higher premiums, hopefully more volume, and so on. So kind of in wrapping up here, so milk quality, all that technology, it requires monitoring the reports. So the key to milk quality in a robot is monitoring these reports 12 hours apart. I say AM and PM. On the left are a bunch of them that we look at. On the right are the typical reports that I look at when I go to a farm to monitor for milk quality. I want to look at the collector, the fetch cows, because I want to know, are these just chronic fetch cows that have never come through, they are what they are, or is there a reason the animal didn't come through? What I'm going to call an udder health alert or an attention report. This is a cow who just got a new alert of some sort, and an alert or an attention is, a longer milking time or a failed milking or conductivity was elevated. So that's really a 12-hour report. That means the animal has appeared for the first time, and at the prior milking in the last 12 hours, everything was normal. There's also what I call an udder health monitoring report that I want to look at, and that's more of a 24-hour or a cow now has clinical mastitis. We're going to keep monitoring her until she returns to normal. That 12-hour report is where we need to make the intervention, go collect the milk sample or check the cow out, see what we need to do, supportive therapy, so on. The 24-hour report, again, is the just managing that animal for the 4 to 5 days where she's going to have abnormal milk if she truly does have clinical mastitis. I also look at failed or incomplete milkings, and I use that to monitor if it's the cow or the specific robot, the maintenance. Robot performance, so I look at the daily milkings per robot and just look at those should stay the same over time. We should be getting very similar milking time, box time, number of cows milked per day, just kind of getting a feel of how each individual stall or box is working. And then I look at the alerts on the main screen. Is there anything that could be related to cows being on the list, either putting them on there as, a false positive because of some failure in equipment, or being the reason that maybe they are on there. So any concerns with this table below? This might be hard to see, I'm not sure, but the idea here is this entire robot, all these values are from robot 1101. And if you go look, the milking time average for the left hind and right hind on this robot are constantly off by 30, sometimes 25, 30, 40 seconds or more. So multiple different cows here, but what this tells me is there's something going on with this robot. So this is a mechanics or a machine issue that we need to go look at. So in wrapping up, robot success, what is it? It's performing daily, weekly, monthly maintenance, any sort of tasks like that as recommended by the manufacturer. So the same thing as I said before, where we can be proactive on our managing milk quality because we can respond earlier. This is the same thing. We got to read these reports and monitor the equipment so we can be proactive in terms of servicing the robot. Monitoring reports at least twice daily, 12 hours apart, 3 times is preferred, again, for cow level and robot level diagnostics. one thing I didn't touch on a lot here, but cows will adapt quicker than people, so don't interfere with the flow of cattle to and from the robot. The whole idea with switching to robots was to give yourself less time of, physical side, cow side, working with them. So if that's the case, sometimes we need to stretch the limits a little bit, and let that cow try to see if she's going to come in. Try to find a way to go check her visually, from without entering the pen, to see if she is fine, or maybe she's in heat, maybe she's down, or she's lame, she's got a bad wheel, something like that. And once you start moving cows to the robot, it's a hard habit to break, and it's a harder habit to break from the human side than it is the cow side. So evaluation or treatment area, you need to have one, set up to do cow side evaluations and treatment that's not in the robot. Observe cows with limited cow to human interaction, and then barn design and feed. We didn't touch, but that's there. So, and wrapping up, why hasn't Joe monitored reports today? I better fetch Joe. So, any questions?
I had a couple of questions for you. So the first is the cameras. You're really encouraging folks to have cameras in the barn. So I'm kind of wondering two things. One, where do you recommend you put these cameras? Is there sort of a method that gets the most valuable video? And then the other is, how do you actually use this video? How do you review it? I'm thinking hours of video, even on fast forward. I mean, is it really, how do you actually use the video?
So in terms of location of cameras, I think you definitely need them where you can see the entrance and the exit of the robot, or, especially the entrance and some exit areas. And then if you can get, you can have them out over the, the freestall or the housing area. I don't think that's as important if you have cow activity and all the other stuff. So it's more right around the robot. And then, again, it's the same thing. You've got these hours and endless hours of data or a video. What do? I think you need to use it and find a way to kind of set up some sort of sensitivity or an alarm report that you're going to look for specific cows, or that a group of animals was last milked at this time. You go start looking from that point to the current. You definitely don't scroll through it every day. It's more of a secondary check if something, if all of a sudden the average milking time goes up on a robot or an entire pen, then you're going to start going and looking at the camera. I don't think it's anything you need to do routinely if numbers are, at or above where you want them to be.
Okay, that makes sense. Rick, I don't know if you can see the chat box, so I'll read the first question that we have. It says, based on your experience, can you give your opinion, let's see a full sentence. Can you give your opinion on what flows, free flow or direct flow, is easier for the flow to the robot?
Yeah, so there's free flow and forced flow. Free flow is probably 85 or 90% of what we see, and that just means cows have free access to go to the robot. There's no, they go in. If they're not allowed to milk, it'll open up and kick them out. Forced flow basically means there's two different ways. Either the cow has to go through the robot to get to feed, or you can have it the other way where they can go from feed to get to the robot. The number one reason we see more free flow than forced flow is more expensive. We're already looking at $3,000 per cow basically in debt just to install the robot. You start adding a barn, a milking center, and all that onto it, adding more gates and electronics to it makes it more expensive. You can definitely get more milkings per cow in a forced flow setting. The other side of it is when you're looking at the whole free flow, let the cow do her thing, you kind of take that away with forced flow. But I don't think one is better than the other. The big driver of free flow over forced flow in my mind is strictly the economics at the time of the initial investment. It's more for forced flow.
Thanks. The questioner just said thanks, Rick. I had another question for you. So on the activity and rumination monitors, so are these systems that have been bought through so are they the systems that come with the robot that I'm trying to get at, or are they separate systems? And is there any advantage or disadvantage to using one or the other? I'm thinking mostly about integrating data.
So most of them are through the robot manufacturer, but when it comes to ID systems or like rumination, there's only a couple manufacturers in the world, and the robotic companies are working with the main manufacturers of that. So you're just finding it under the robotic company's brand name, but it's actually done by, SCR is one of the major companies that does rumination activity tags and so on, and they work with some of the robotic companies. So I think it's easier if it's linked to the system, because then you can mirror it with all the other data.
Okay. And then I have just one more question. So you were talking about mastitis and contagious organisms. So in a robot system, do you see like an increase in mastitis levels, and they're based on contagious, or just when you do have mastitis in a robotic system, it tends to be contagious? And then I wonder about, you're picking things up earlier, so do you kind of, because you're watching it, you see it?
Yeah, so one thing quickly on contagious organisms, I should have more or less stated maybe what I would call contagious transfer. The robot doesn't know if it's contagious versus environmental, and it can just as easily transfer Klebsiella or E. coli as it can Staph aureus or Mycoplasma. So it's more contagious transmission, which we would consider transmission, through the milking equipment at milking time versus out in the cow's environment. That is a bigger risk just because of the number of additional cows we're milking per robot. Now, the way that's minimized is partly because we milk at the quarter level. All these systems have some sort of back flush that goes on, or, pure steam for sanitizing. So it's just really making sure that everything, is in tune. It's like any other farm. Some farms you go to are very well managed, have low mastitis. Some are very well managed, have high mastitis. Some farms are very poorly managed, have low mastitis, and some are poorly managed and have high mastitis. It's the same in robots. It's no different.
All right, so it's 12:15, so we need to wrap up. Rick, thanks very much. This was an excellent presentation, really practical and useful for us. So thank you again for being our presenter today. And folks, thanks for joining us this afternoon.